The United States not only leads the world in wood pellet production, but is also one of the leading powerhouses in the field of plywood production. With modern industrial scale and global top output, the U.S. plywood industry is worth tens of billions of U.S. dollars annually. And today, you and I will explore together the entire plywood processing process in the most modern factories in America. The story begins with tree planting. Professional foresters plant pine seedlings 8 to 12 inches tall in the winter, from December to March. They use GPS-guided planters, placing each tree 6 to 8 feet apart, creating a density of 600 to 800 trees per acre. Each tree is planted at a depth of 10 to 12 inches, ensuring roots contact soil, well, and perfect drainage. In the first 3 to 5 years, young pine trees need special care. Foresters use selective herbicides to control weeds competing for nutrients. They also perform thinning, cutting weak trees, so healthy ones grow stronger. This stage reduces density from 800 down to 400 to 500 trees per acre, allowing trees to reach larger trunk diameters. After 20 to 30 years of patience, pine trees reach harvest size. Trees are 60 to 80 feet tall with trunk diameter 12 to 18 inches at diameter at breast height 4.5 feet from the ground. Each acre of mature forest contains 100 to 150 cubic meters of wood. At this time, foresters mark ready trees with colored paint, preparing for harvest season. Wood harvesting is a job requiring precision and high technology. Feller Buncher, a giant machine weighing 40 tons with powerful hydraulic arms, clamps the tree trunk tight, saws off the base in 10 seconds, then places it gently on the ground. This machine can cut 100 to 150 trees per hour. Hydraulic shear blade cuts clean without shattering wood. After cutting, the skidder, a specialized log skidder, gathers tree trunks and transports them to the landing area. The skidder uses a grapple claw or winch cable to pull 5 to 8 logs at a time over hilly terrain. At the landing, the delimber removes all small branches, creating smooth logs ready for transfer. Finally, the log loader, a specialized forestry crane, stacks logs onto logging trucks. Each truck carries 25 to 30 tons of wood, equivalent to 20 to 25 logs. Logs are stacked tied with safety chains. The truck convoy runs on the highway, carrying fresh wood from forest to sawmill. The journey is usually 50 to 150 miles long. Time from cutting to factory is only 24 to 48 hours. Welcome to the modern sawmill. The log yard is the log receiving area 20 to 30 acres wide with thousands of logs sorted by type. Giant front-end loaders move logs to the log deck. Metal detector systems scan each log to detect nails, metal before entering the production line. Logs are sprayed with water continuously to keep moisture and avoid cracking. The first step, debarking. Logs are fed into the debarker, a giant rotating drum with steel teeth. As the log spins at 20 to 30 RPM, scraper teeth strip bark clean in 30 to 60 seconds. Stripped bark falls onto a separate conveyor, then is reused as mulch or biofuel. Smooth, creamy white logs are ready for the next step. Next, Is log heating an important stage? Logs are put into vats soaking in hot water 180 to 200 degrees Fahrenheit for 12 to 24 hours, or steam chambers with steam 212 degrees Fahrenheit for 8 to 12 hours. High temperature softens lignin in wood, making peeling veneer easier and reducing breakage by 90%. Moisture content increases to 60 to 80%. This is the heart of the process, veneer lathe. Hot logs are mounted on the lathe, a giant lathe. As the log spins at 100 to 150 RPM, the peeling blade presses close, peeling off a thin, continuous veneer layer like a roll of paper. Veneer thickness 1/10 inch, 2.5 millimeters. Width 4 to 8 feet. One 8-foot long log produces 200 to 300 square feet of veneer in minutes. This scene is truly hypnotic. Wet veneer is immediately transferred through the Clipper automated cutting machine, cutting veneer into standard sheets 4 by 8 feet or 4 by 4 feet depending on product. Optical scan sensors detect defects like knots, cracks, then cut to remove bad parts. Recovery rate reaches 85 to 90%. Veneer drying is extremely important. Sheets are fed into a jet dryer, a drying oven 100 to 150 feet long, with 3 to 5 temperature zones from 300 degrees Fahrenheit to 500 degrees Fahrenheit. Veneer moves on roller conveyors through zones. Hot air blasts from above. Moisture content drops from 60 to 80% down to 3 to 6% in 4 to 8 minutes. This process needs precise control to avoid warping. After drying, veneer is sorted by quality. QC workers and automated scanners check each sheet according to APA standards. Grade A, no defects. B, some small knots. C, large knots, okay. D, many defects but usable. Sheets are stacked into separate stacks. Some defects are patching machines fit small wood pieces into holes. Now layup core veneer is spread on the table. Glue spreader machines coat evenly with phenol formaldehyde or soy-based adhesive. Layers are stacked with perpendicular grain direction, cross grain. This is the secret of plywood strength. Plywood 3-ply, 3 layers. 5-ply, 5 layers. Every layer alternates grain direction 90 degrees. Hot press the decisive step. Glue-coated veneer stacks are loaded into giant hydraulic hot presses, pressure 200 psi. Temperature 280 to 320 degrees Fahrenheit. The pressing process takes 4 to 8 minutes, depending on thickness. Pressure and heat cure the glue, bonding layers into a solid panel. One press can process 30 to 50 sheets at once. Plywood coming out of the press is still hot at 250 degrees Fahrenheit. They are cooled by cooling racks or fans in 15 to 30 minutes down to 100 degrees Fahrenheit. Then, trim saws cut off uneven edges, creating standard size 4 by 8 feet, 48 inches by 96 inches. Laser guides ensure perfect straight cuts plus or minus 1/32 inch. Sanding and surface finishing. Sanding machines with abrasive belts. Grit 80 to 120. Sand both sides of plywood, creating a smooth surface. Some high-end products go through 2 to 3 sanding times with increasing grit. Dust collection system sucks 99% of wood dust. Then conditioning 24 to 48 hours in warehouse controlling humidity 40 to 50%. final strict quality inspection, QC inspectors check each panel, thickness, tolerance plus or minus 1/32 inch, flatness, bond strength, delamination test, and moisture content, 6 to 8%. Panels meeting standards are stamped with APA, the Engineered Wood Association trademark, ensuring PS1 or PS2 standards. Then, wrapping machines wrap moisture-proof plastic. Bundles 50 to 75 sheets per unit. The final journey. Bundles are loaded onto 53-foot trucks carrying 40,000 to 50,000 pounds and distributed to lumber yards. Home Depot, Lowe's across the U.S. Each year, this industry produces 18 to 20 billion square feet of plywood from a young pine tree 20 to 30 years ago. Now, the plywood sheet is ready to build your dream home sustainable, strong, and environmentally friendly with SFI certification. The U.S. is not only a nation possessing the world's leading modern heavy industry, but is also one of the countries with the largest wood pellet manufacturing industry, ranking second globally, thanks to abundant raw materials and a development orientation for a green environment. Today, you and I will go together to explore the wood pellet processing plant of the world's second-ranked nation. The story begins 12 to 18 years ago when foresters started sowing pine seeds. In the vast lands of the southeast, they plant loblolly pine, the fastest growing species in North America. Each acre of land can hold 400 to 600 seedlings. Ideal conditions: sandy clay soil, rainfall of 40 to 60 inches per year, and warm year-round temperatures of 60 to 80 degrees Fahrenheit. Saplings only 6 to 12 inches tall are planted carefully with 6 by 8 feet spacing, ensuring optimal growth space in the coming years. Over the next 12 to 18 years, a growth miracle takes place. From tiny seedlings, loblolly pine trees grow at a rate of 3 to 5 feet per year, thanks to the warm, humid climate and abundant sunshine of the south. Foresters provide periodic care, weeding in the first 2 to 3 years so saplings don't compete for nutrients, thinning trees when the forest is 8 to 10 years old to remove weak trees, and monitoring pests. By year 12 to 18, pine trees reach a height of 60 to 80 feet, trunk diameter of 10 to 16 inches, ready for harvest. Each acre can yield 60 to 120 cubic meters of high-quality wood. The harvest season arrives from December to March when wood moisture is lowest. A professional logging team uses modern machinery. Feller buncher, a giant machine that can cut, lift, and stack 100 trees per hour. A giant hydraulic claw hugs the tree trunk tight. A rotating disc saw cuts the base in seconds, then places the tree down gently. Next, the skidder, a powerful log dragger, gathers and pulls dozens of tree trunks to the landing point. The entire process is fast, efficient, and safe, minimizing impact on the surrounding environment. Welcome to the Enviva Wood Pellet Manufacturing Plant, one of the largest factories in the world with a capacity of 750,000 tons per year. The first step is receiving raw materials. Trucks dump wood chips, sawdust, and wood waste onto a giant storage yard wider than 10 acres. An automated management system tracks each wood type: fresh pine wood, 50 to 55% moisture; sawdust, 30 to 40% moisture; recycled wood. large loaders move and stack wood into mountains 20 to 30 feet high. Temperature sensors monitor continuously to avoid spontaneous combustion. Every day, the factory receives over 2,000 tons of material. All are byproducts from the wood industry. No need to cut separate trees. From the storage yard, wood is fed into the grinding system by high-capacity heavy conveyor belts. The first step is coarse grinding by a giant chipper with hardened steel blades. Large wood logs are torn into small pieces 1 to 3 inches in a few seconds, capacity 100 tons per hour. Terrifying noise. Then the hammer mill with dozens of steel hammers weighing 50 to 100 pounds, rotating at 900 RPM, smashes wood chips into coarse powder form under 1/4 inch size. Wood dust flying thickly is collected immediately by an industrial dust extraction system, ensuring a clean and safe working environment. After grinding, wood powder has high moisture, 50 to 55% too moist to pelletize. Therefore, the next step is drying, the most energy-intensive stage. Wood powder is put into a rotary dryer system, a giant rotating oven 60 to 80 feet long, 10 to 12 feet in diameter. Inside, hot air 350 to 600 degrees Fahrenheit from a biomass burner blows through the tumbling wood powder. In 15 to 20 minutes, moisture drops from 50 to 55% down to only 8 to 12%, the ideal level for pelletizing. Special thing, fuel for the dryer is exactly wood dust and defective pellets from the process, completely self-sufficient, needing no external energy. Truly sustainable. Dry wood powder is cooled quickly down to 85 to 95 degrees Fahrenheit by industrial cooling fans, avoiding burning when pressing. Next is the important conditioning and mixing step. Here, dry wood powder is sprayed with additional steam or vegetable oil, 1 to 2%, to increase moisture to exactly 10 to 12%, the optimal moisture for natural lignin in wood to act as a binder. Some formulas also add a little cornstarch to increase pellet durability. The industrial mixing system ensures every powder particle receives enough moisture. No need to add glue or chemicals. Wood bonds together naturally under high pressure. This is the heart of the factory, the pellet mill system. Conditioned wood powder is fed into high-capacity pellet mills. Inside, there is a metal die 2 to 3 inches thick with thousands of small holes 6 millimeters or 8 millimeters in diameter. Rollers weighing tons rotate, pressing wood powder through these holes with pressure up to 5,000 to 10,000 psi and generated temperature 180 to 220 degrees Fahrenheit. Under this terrible pressure and heat, lignin in wood melts and binds, turning loose wood powder into solid, hard, golden brown pellet strands. Rotating cutter knives outside cut pellets to standard length 1 to 1.5 inches. Each machine produces 3 to 5 tons of pellets per hour. Freshly pressed pellets are very hot, 180 to 200 degrees Fahrenheit, and soft, needing immediate cooling. They are put through a fan cooling system. Cool air blows through a pellet layer 12 to 18 inches thick for 10 to 15 minutes. This process lowers temperature to 75 to 85 degrees Fahrenheit and hardens pellets, increasing durability from 95% to 98%. Cooled pellets have a beautiful dark brown color, smooth surface when tapped, revealing a dense compressed wood structure. Quality check right here, measuring hardness, durability, moisture, calorific value. Only pellets meeting EN plus A1 standards are transferred forward. Next is screening to remove wood dust and defective pellets. Cooled pellets go through a multi-deck vibrating sieve system. The top deck has large 10mm holes. Oversized pellets fall off to go back for grinding. The middle deck is standard 6 to 8mm mesh. Good pellets fall through. The bottom deck has small 3mm holes retaining standard pellets, letting dust fall through. Wood dust is collected as fuel for the dryer. Defective pellets, too long, too short, cracked, are detected by AI camera robots and blown aside, also returning as fuel. Standard pellet rate, 92 to 95%. Perfect pellets, 6mm diameter, 20 to 30mm long. Uniform color, smooth surface, ready for packaging. Before packaging, pellets need to pass a light sterilization step to ensure biosecurity when exporting, especially to EU. Pellets go through a heat treatment chamber with superheated steam, 212 to 250 degrees Fahrenheit for 2 to 3 minutes, killing bacteria, mold, and insects without changing pellet structure. Some batches are also lightly irradiated. This process meets ISPM 15 international quarantine standards, allowing products to go around the world without worrying about disease. This is the reason U.S. wood pellets are favored globally, absolute quality and safety.
Certified.
Finally, packaging. Pellets are packed in 3 specifications. 1. Small 40-pound bags for households. Automated machines weigh, pour pellets into plastic or craft paper bags, seal mouths, print labels, and stack on pallets. Speed 80 bags per minute. 2. 1-ton jumbo bags for commerce cranes lift large fabric bags, pouring pellets from above, sewing bag mouths. 3. Bulk pouring straight into trucks or cargo ships for large power plants. Each 40-pound bag is fully labeled. Technical specifications: 6mm diameter, 25mm length, moisture less than 10%, ash less than 0.5%, calorific value 8,200 BTU per pound. Origin made in USA. EN plus A1 certification, expiration date, and traceability batch code. Final quality check ensuring every batch meets highest standards. Automated sampling systems randomly take 1 bag per 100 bags for comprehensive testing. Checking weight, rejecting underweight bags. Measuring moisture by sensor machine must be less than 10%. Burning pellet samples in calorimeter oven calorific value must reach 8,000 to 8,500 BTU per pound. Measuring ash rate after complete combustion must be less than 1%. Testing pellet durability by vibrating machine good pellets don't crumble. All data is recorded in the traceability system. Pass rate 99%. After inspection, products are moved to the vast storage warehouse. Forklifts stack pallets 15 to 20 feet high in dry warehouses with humidity controlled less than 60%. Each pallet holds 50 bags of 40 pounds, 1 ton total. WMS warehouse management systems track exact location of each pallet by barcode and RFID, automatically arranging FIFO output. A part of the warehouse is reserved for bulk pellets, giant silos 100 plus feet high, each silo holding 5,000 to 10,000 tons of pellets. From here, pellets will be distributed domestically or transferred to ports for export to Europe and Asia. The U.S. wood pellet industry is worth over $2 billion per year. Logistics, the important part, bringing pellets to customers. For the domestic market, trucks carry 40-pound bags to Home Depot, Lowe's, Tractor Supply stores all over the U.S. Tanker trucks carry bulk pellets to biomass power plants. For export, this is interesting. Containers or giant bulk carriers are loaded full of pellets at Chesapeake or mobile ports. One ship can carry 40,000 to 60,000 tons of pellets. The journey crossing the Atlantic takes 10 to 14 days to ports in UK, Netherlands, Denmark, where U.S. wood pellets replace coal in large power plants, reducing 80% of CO2 emissions. Wood pellets reach consumers for many different purposes. In the U.S., millions of families use pellets for pellet stoves, modern heating devices, 85 to 90% efficient, automatically feeding pellets and controlling temperature. An average family uses 3 to 5 tons of pellets per winter, costing only $900 to $1,500 US dollars, 30 to 40% cheaper than heating oil. Farmers use pellets as animal bedding, absorbing moisture well and deodorizing naturally. BBQ restaurants use pellets to create smoke for smoking delicious meat trays. Blacksmiths and ceramicists use pellets as fuel for high-temperature kiln. In Europe, the largest market for U.S. pellets, millions of families in UK, Germany, Denmark, Sweden use pellets for winter heating. Automated central heating systems, controlled by smartphone, extremely high efficiency. More especially, giant power plants like Drax in the UK burn millions of tons of U.S. pellets to generate electricity, replacing coal, creating power for 4 million households. They call this carbon-neutral biomass energy because replanted trees absorb CO2 equal to the amount burned. Wood pellets are the key to global green energy transition. And that is the complete journey. From young pine trees planted 15 to 18 years ago in southern U.S. forests, going through sustainable harvesting, taking only wood residues, to the high-tech processing procedure with 12-plus scientifically precise steps, finally turning into wood pellets, a renewable energy source heating millions of families and replacing fossil fuels globally. This is not just a story about a product, this is proof of sustainable forestry, technological innovation, and commitment to a greener future. Each small pellet contains 15 years of tree growth and modern scientific intellect.